Hello and welcome back to CM4D Basic Training. In this module, what we will be looking at are different ways of using dynamic styling for our objects and annotations, and ways of sorting or categorizing our data. So the three main ways to do this is to use what are known as events and data sets, along with some settings in our objects on the white space in order to have it change the display based on the type of data it's reporting. So event-based styling. There is also styles based on using scores, which is a function which we pass values into, and the score function will categorize them according to their different values in bins that we set up, assign either a weight or a color to particular bins that values fall into, and that can be used later on to tally up our values or to display them in a benchmark chart, which we've seen in one of the previous modules regarding graphs. And then finally, there is something called conditional styling, which can be used as well for certain annotations, where we can assign different styles based on certain logic conditions, similar to setting up events and data sets, except that the conditions are set up in the style itself, and we can have multiple conditions that add on to each other to add more types of styling to a chart or a object as those conditions are met. So there's three main ways of displaying dynamic changes to our objects, and we'll look at all three in this module. So the first way that we'll consider is how to use events in a data set along with some settings in your annotation in order to get it to display certain color or style based on the information it's reporting. So in previous modules, we talked a bit about some of the functions in a data set. Right now, I'll be looking at this page for text boxes, and I believe that it's getting its source of data from this data set labeled A. If I right click and go to properties, go to data source, yes it is, I see here. To get into that data set, we can just click right here on modify, and this will take us into this data set that it's connecting to. So if I hit modify, I'm now in the A data set. The event tab we talked about before, this is where we can set up different triggers, trigger 1 and 2, based on certain logic conditions that we can select. Currently we have out of tolerance selected, and again what this is doing is looking at all the values in the data set, checking to see if the values are in or out of tolerance, and if it meets this condition it's considered a non-conforming value, and an electronic flag is noted on that particular value. So this is the first step of using events for styling, is to set up the event in the source of data, whether it's the data set or the data stack that you're using. Set it up here for out of tolerance, and then in the actual objects themselves, for instance, if I right click on this text box and go to properties, in all the annotations there will be a general tab. If we click here on general, we will see that there is a section called event operations, and this is where we can have this object display a certain style based on whether it has data which has triggered one of the conditions that we set up in the data set. So there's a few options when to draw. We can say always draw. We can say draw only on trigger 1. This means that this object will only be visible if it's showing data that has been triggered by that first event that we set up, which was out of tolerance, draw on trigger 2, draw when both are triggered, draw when either is triggered, and again, always draw. So you can have certain objects be invisible until the event is triggered. If I did something like that, I could click here on draw on trigger 1, only on trigger 1, and then if I hit OK, we notice that the object has disappeared. It's still there, but the software is not drawing the the text box, because it's displaying data that has not been triggered by this condition. In other words, the data that it's displaying is not out of tolerance, and so therefore it doesn't draw. If I wanted to transfer this condition to all the other charts as well, what I can do is hold shift while clicking on these charts. I'm sorry, these text boxes. That's what these are, text boxes. And then while I hold shift, if I right click on the object that I changed, which is here, I can choose copy properties, and it will copy the properties of this last object that I selected using a right click to everything I selected first. So if I do that, I am updating all the other objects with that setting that I turned on here, where I said draw only on trigger 1. So now all of the text boxes that I have here are drawing on trigger 1. I also locked this object. This is a view object. If you don't want to click on this while selecting other boxes, what you can do is if you right click, you can go to miscellaneous operations and choose lock. And if you select that and then click on the outside, and this is true for any object, the object becomes locked so that when you click on it, nothing happens unless you hold control. Then I can click on the object. So it just makes it control centered, where you have to hold that button in order to select it. But now that that's done, if I draw a box around everything, it will only highlight the charts that are unlocked, or the text boxes that are unlocked. And if you notice, only one of them shows. So that means this text box must be one that is showing a value that is out of tolerance. And so we're seeing how that condition, only draw on trigger 1, functions, and that functions the same as the others. If I want to show another way that this can work, I'll choose always draw, and I'll say here under event trigger operations, use style to indicate trigger. So what this will do, instead of deciding to draw the object at all, it will always draw it, but I can choose a particular style to use if it's displaying data that is a non-conforming value from the data set. So here, with this use style to indicate trigger, basically we can create different styles, which we went over in a previous module, showing how annotations can have different styles applied to them. I'll cancel out real quick, but here under document, styles, we'll see a styles and scores. These are some default styles that come in the document. If I click here on scores, which we'll also look at later, you might see some default scores. These came by clicking on this build examples. So if you click that and you did not have the scores and styles, then they will appear here and here. And again, styles are different combinations of these tabs, whether it's pen, brush, border, font, format, and conditionals. where you can turn on certain colors for your font type, the perimeter of an object, the interior of an object, and save that styling off to be used in any other object. So what we're doing here, if we go back to properties, we're going to go to general and we're going to say use style to indicate trigger, and we'll say that if it's reporting a value that is non-conforming for this event 1, we'll click on style and say we want it to use this tall eval out. It can be any other style that you've created, but in this example we're just using this style. So if we do that and then hit OK, let me go back. We want to make sure that this is turned to always draw, by the way. So we'll do that, use style to indicate trigger, this style. The object redraws. It's looking the way it always did because, again, it has a value that's not out of tolerance. But if I do the same thing as before by highlighting all the other charts, if I hold shift, I see that this one's highlighted as well. I'm going to click once so that it's not selected, and then right click while I'm holding shift and choose copy properties. And now I'm copying these properties onto all the other charts. And I see that the one that drew when we use the other method is now the one that is having a different style, this out of tolerance, based on these settings here. So again, we're seeing here for the object itself, and if we have a chart, we can do that for an embedded object as well, to have something draw if the object is displaying data that's not conforming to the settings in our data set that it's connecting to. So we can do that for text boxes, for charts as well. For instance, if this was displaying something that was out of tolerance, we could have, if I go to edit and click on the label here, if I right click and go to properties for this, this has a general tab as well. I could turn it on for this. And then if this was displaying any data that was out of tolerance, this feature name would turn red based on the styling. So it can be applied to the object in general, or it can be applied in cases where you have a chart and you have other annotations inside this object. You can apply it to any one of those annotations. Also to tables, if we go to table annotations, where we had a table like this that was displaying the contents of a data set, I believe this table was looking at this table data set. So if I go into this by clicking modify, I'm going to go to the event of that data set. I have here value greater than or equal to 0. So I was using a different method, but if I kept this and go back to the general tab for this table, I can still use this and choose that option, and what will happen is if I go back into the data set, into event, any value that's greater than or equal to 0 should change to the style that I chose within this table. So if I do that, it's going to make red all of the positive values within this table based off of the event setting that we created for the data set it's connecting to, which again set value greater than or equal to 0. So again, this is just showing how this type of style can be used, or this method can be used to change the styling of cells in a table, of information in a chart or graph, or text boxes themselves by combining the options for this general tab here with the options that we set up for the event settings of the data source for that object. So that's one way that we can use styling in CM4D. Another way is to create what are known as scores. So in certain cases where we don't have the actual, where we don't want to queue off the actual values in the data set, for instance here, all of these data values are in the data set itself. If we right click and go to view data set and grid, we're checking these values based off the event settings to see if they're intolerance or if they are above 0 or some other event that we set up. But sometimes we have cases where we have like this table that we created where this data here is not directly stored in the data set, but instead we are using variables to calculate statistics based on that data. So because this data is not in the data set itself, we can't use the event settings to make these cells change color based off these calculated values. So that's where we have to use a method like scoring, where these get sent to a function to be evaluated, and then the function will tell these cells in the table or whatever object has sent the information what color it should be based on that value. So a score is what we'll use for evaluating something like this. And as an example, if we go to the document and go to scores, by clicking on this build examples, it creates a few default examples for us within the software. Once that's done, for instance, if we go here to this CPK, we can click on this by going to edit, and we'll see how a score looks. So this is a score here. Where it says position of start bin, actually there's information about this in the help file. So if we go to help, topics, we're going to go to applications, CM4D, classic, let's see here, data, actually we're going to go to here, documents, document properties, document styles, document scores. So here we have document scores, and then down here it says related concepts, scores, understanding bins. We'll click here, and this has information about the nature of a score. So again, it's like a sorting mechanism where you feed it values and it puts those values into different buckets or categories. And you create the buckets or categories to determine the boundaries between those categories so that the values being fed to it will fit into one of those buckets. So the buckets are known as bins, and it says here scores divide data into bins. And they all start with what's known as a start or default bin, and basically that will have a default position. So there is 0 inclusive and 0 exclusive, where the default bin will always be in the middle of the other bins that you create, and it would have all the values that are less than 1, between -1 and 1, basically. So inclusive means that if you have a default bin at 0 and then you have a bin above at 1, if the value being fed to it is 1, it will fall into this value. If it was exclusive, then if you gave it the value of 1, it would actually, it's the other way around. So you have a 0 value bin. If it's inclusive, it means that if the next bin is 1 and you feed it a value of 1, it will fall into that next bin. If it's exclusive, it means that if you start with a 0 bin and you have a bin above it for values 1 and up, the value would have to be 1.1 or something bigger than 1 to fall into here. So it's about whether the value falls into the same bin or the next bin if what's being fed is the same as the boundary. And this will make a little more sense as we look at the examples. But you have 0 inclusive, 0 exclusive. You have lowest value, which means that the default bin will receive the smallest values being fed to it from whatever object is the source of the data, and those are inclusive by definition. And then you have largest value as well. So there's lowest value, and then there's largest value, where it will have the highest values, and all the bins that get created by you will have values that are lower than the start bin. So a way of showing this, in the case of CPK, we have CPK values here, and if we look at this a certain way, let's say that we want to have the values to be categorized by the score. We could set up a series of bins, and this is just a graphical illustration here. And let's see here. If I do I'll just do something like this. This line with this terminator actually that's a little too big, so I'll do this. This represents values being added into the bin, and we're trying to feed CPK values into a score. And CPK is a statistic that helps you see how consistent your process is. Basically, it aims to show you how reproducible values are. That there's small variation in the process or in the deviations of some values. So for CPK, the higher the number, the more consistent you are in reproducing values that are clustered together. So you aim for a high CPK. So let's say that CPK values that are 1.33 and bigger are very good. And then CPK values that are between 1.33 and 1 are okay. And I will reduce, let's do this wrap text. And then here, values that are less than 1 are considered bad. So we have a series of CPK values here that we want to feed into the score so that we can change the colors. And we want to set up a score so that the biggest values, which are 1.3 and bigger, will be considered very good. And we want those cells to turn green. Anything between 1.33 and 1, we want to be yellow. Anything less than 1, we want to be red in general. That will be the idea behind this sorting mechanism. So in the score itself, if we go to Document, Scores, we have this one called CPK. If I hit Edit on that, you see that it does something similar to this, except it has a few more bins, but it's starting with the highest value. So this start bin will receive the highest values of everything. After that, we'll have data that has values less than 1.33. After that, there's data with values less than 1. After that, less than 0.5, less than 0, and then there's what's known as an error bin. So if the start bin is set at the highest value, whatever gets passed to the score by this object, the biggest values will always go into the start bin. So the boundary between this start bin and the next one underneath is determined by what we set as the boundary for this bin. So if we double click on this, the boundary, which is called value text for bin boundary, is set to 1.33. This is just a description here for the bin label. This is text to assign for benchmark purposes, and this is the actual style that was generated when we hit that button in the document defaults. It will be using this CPK less than 1.33 style. But this value here that's typed in, 1.33, that is the value that determines what falls into this bin and what falls into this bin. So anything 1.33 and greater will go into the start bin. Anything less than that will fall into this bin. And so the value underneath that is values less than 1. And we have here the value text for that being 1. So this means anything that is less than 1 will fall into this bin. Here, if it's less than 1.33, it falls into this. So highest values will go into here. Anything less than 1.33 will fall into this. And then anything less than 1 will fall into this. And then for this bin, the value is 0.5. So anything less than 0.5 will fall into here. So each bin, because this is the start at highest value, the bottom of this bin is determined by the top of this, and the bottom of this is determined by the top of this, the top being this value text for bin boundary. So in this way, in this example, these bins are stacking beneath each other in smaller and smaller values. And then finally we have this error bin, which is just a special case. It's labeled error, and it will receive what's known as error data. So when CPK cannot be generated, then values will fall into that bin. So that being set up and styles assigned to those different bins, if we want to get this cell or these cells to display colors based on that score, what we could do is go to Edit, click on this cell, and then if we go to Cell Properties, where it says Style, we would turn off Use Table Style. And then where it says Embedded Style, we could click and choose Use Score for Style. So once we do that, we would click Setup and tell the system which score to use. In this case, we'll click on CPK. This variable to score, we can leave that blank. That's if we didn't have any text here, but since there is the CPK variable already in the text field for that cell, this is the calculated value that's going to be passed to the score, so we can leave this blank. So if we do that and hit OK and then exit, it will now add colors to the cells based on what the CPK value is in the score evaluation that we set up. So you create the bins, you assign boundaries to each bin depending on what the start bin would be. Either all the bins, if the start bin is the highest, all bins are created lower than that. If the start bin is the lowest, you'll create bins that are higher. Each bin has a color assigned to it, and then the object will pass the values to the score. The score will put the values into the appropriate bins, assign colors to them, and then assign those colors back to the object to display the appropriate color that you see here. So scores are a little more complicated, as we've seen, than using the event options in a data set, but they are necessary in cases like this where you want to do conditional styling or color coding based on a calculated value, whether this is a table or a text box or some other object. If you're using a variable, then scoring would be the main method of getting that object to change color based on the value. So the last method of getting objects to change color is something called conditional styling. In a way, it combines the nature of both what we saw with the events in the data set with what we're seeing with conditions being set up for scoring. And it can be used to change the coloring of certain objects if it's available within the styling. So for instance, if I go here to edit and click on one of the cells in cell properties, I only have embedded style and use score for style selected. But in other objects like text boxes, I have something called conditional style, which can be used. And conditional style, if I go here to styles, it is just another style that can be created, but within that style, you have another tab called conditionals where you can add different logic rules that will determine which of these other styles gets used by this conditional styling. So, as an example, let's do this. If we go back to text boxes, what we're doing here is we're looking at, in these text boxes, what's known as the mean value for the data, or the average for this data. Let's say we wanted to know, or we wanted the styles to change based on what that number is. We could create a score for that if we wanted to, or we could create a conditional style. So for conditional style, I can go back to styles here, and let's say that we create a new style. So I clicked on new, I have the style 1, I'll hit edit, and I will call this average conditional. I can give it a base style of just default, that's fine. All of that will be the same, I'll keep everything base. But then here, where it says conditionals, this is where I can add how the style would change based off of whatever the value is. So if I hit add, I can add in logical conditions here. So this condition, this label, I can call this average less than 0. So here, the compare text would be a particular variable. So the variable I want to compare here would be tilde mean, tilde, the average. So that's the compare text, or the thing that I want to evaluate. The operation for that is if this mean is less than value less than 0. And if this is the case, let's say that I want the style to be this CPK value less than 0. So I can do that. And if I hit OK and OK, and then right click, go to properties, here under style, I can choose use conditional style, and then under general, I'll make sure to turn off this event trigger properties. I don't want this working at the same time. So I will turn that off and make sure this is saying use conditional for style, and then click on setup and choose that style that I just created, average conditional. So if I do that, it changes this to that color for less than 0. So it's using that conditional style right now. Let's say I want to apply this to all the other charts. I'm holding shift and clicking on all the text boxes that I want to change. And if I right click and hold shift and right click on the main one here and say copy properties, and it'll copy the properties of this onto all the other text boxes. And so what I'm seeing here is that the style is changing in cases where the value is less than 0. So for negative values. So if I wanted to go even further and maybe add or build a style on top of that, I could say if the value is less than 0, and also if it's less than negative 0.3. So let's say I go here back to styles, and in this case I'm going to create a new style. I'm going to go here and I'm going to call this less than negative 0.3, just for illustrative purposes. And in here, the only thing I'm going to do, I'm not going to change anything but the font, where I'm going to tell it to underline here. So if I do that and then hit OK, if I go back to the average conditional, go into edit for that and go back to conditionals. Let's see, average conditional, edit. Or was it the custom style? Let's see, let's do this. Hit close. This is using average conditional. So if I go to styles, average conditional, edit. So I have the one conditional there. I want to add a new conditional. I'm going to call this average less than negative 0.3. Again, the compare text can be mean. The operation will be value less than, and then the value can be negative 0.3. If that's the case, the style I want to use is less than 0.3. So what this will do, less than 0.3, hit OK, and close. What it's going to do is add the underlying that I put in that style on top of what it did by making the box red for the first style. So it's compounding or adding styles together based on how many of those conditions are being satisfied. So in that way, with conditional styling, it's not just one style or option that you can work with, but you can have a series of conditionals that you can set up based on different rules, and it will go through them one by one, and all the rules that it'll apply, it'll add the styling that you've assigned to it and put them together so that you don't have just one style, but a composite made of all of the different conditions that fit the data that's being displayed in your object. So in that way, you can compound or add together different styles like we're doing here. It's adding together the style for values less than 0 and adding into it a style for values less than negative 0.3 with the underlining that I chose for that. So that's a simple example but it's illustrating how conditional styling can be used to compound or add together different styles for logic conditions all together in one object. So I know that's a lot to cover, but those are the three main ways that we can have data formatted differently based on the values. First way is again using the event settings in a data set along with the options for either the object or, in a case of a chart, objects within it. To use the General tab event operations to indicate a certain style based on the data in the data set. We can use scores, which are shown here, and make a lot of use for tables where data gets evaluated, calculated data based on the score bins that we create. And then we can use conditional styling for text boxes and other objects if that option is available here under the style to evaluate the data for that feature based on whatever variables and styles that we set up here in the conditional style, where we set up the conditionals and tell it what style to use based on which condition is activated for our different options here. And we can have as many as we want in this field. So those are the three main ways, again, that we can have data formatted so that the display is different based on the value. Thank you for attending this particular module, and look forward to seeing you for the next one.